Hey everyone, today we're going to be analyzing relationships among variables in charts and graphs. Now, that could be kind of confusing and a lot of big words, so let's kind of break this down. So, charts and graphs create an easy way to compare two items. So, two items we can represent as variables. Something that you're going to see in math and also in science class are things called the independent and the dependent variable. So, again, big words, let's break them down. The independent variable is the item that determines the other value and is often put first in a chart and on the x axis of a graph. So, if you are doing our experiment, which was that amount of words in a specific amount of time, that amount of time determines how many words that you were able to write down. So, the independent variable in that case would be the time. And then the dependent variable is found using the independent variable. So when we were doing our example, we found the amount of words by actually timing ourselves and seeing how many words we can get in that amount. So it is graphed on the y axis. So again, in our example that we did in class, the independent variable, which is on the x axis, was the time, and the dependent variable, which was the amount of words that we typed, was on the y axis. So we can find the values of independent and dependent variables by using charts and graphs. This will help us compare items such as distance and time and income and profit. So, again, if you want to do anything in your future that requires you to analyze data, which hint, hint, it's going to be lots and lots of different jobs, pretty much all of them. You're particularly going to be looking at income and profit. So, again, charts and graphs help us compare two things. Distance and time and income and profit are just two of those examples. So let's take a look at finding the other variable in a chart. So again, we're comparing two things. In a problem, you might be given one of the variables, and it's your job to find the other. In this example, in the chart below, find the amount of bikes that you can rent for $535. So you're given a chart, they have something labeled either going side to side or up and down. It really depends on what kind of chart it is. And we need to find how many bikes you can rent for $535. Now, this is an example that's like kind of bang in your face. Sometimes you have to look in between numbers and things like that. So, this is just kind of the basis, and we are going to be working together on making it a little bit harder as we move along. So, step one is to find the title of the column or row that you have the amount for. So, in this example, we know that it costs $535. That's the information we know for sure. So, I know the rental cost. That is where I'm going to look at in my chart. Next step is to find the amount that you have and look at the amount for the other variable at the same spot. So in this example, I'm going to find my rental costs of $535, and I'm going to look at that same spot or in that same column right above to tell me how many number of bikes that I can rent for that. And that will give me my answer of 10. So again, I found the information that I knew in the chart. I went to the other variable and I saw what number was associated with that. So in this case, 10 bikes for $535. Okay, finding the other variable in a graph. We practice this a little bit in class, but it's good to have notes down so that you can refer to it when you need to. So in this example, you need to find the number of bikes that you can rent for $400. So, step one, find the access with the information that you know. So, I got a graph right here. Should have a title, forgot about that. And I have the x axis that's labeled number of bikes, and the y axis that's labeled rental fee. So, I'm going to find the amount that I know, which is that I have a rental fee of $400. So, got my rental fee. That means that I'm looking at my y-axis. Step 2, find the amount that you have and move to the dot or the line on the graph. So I did this in orange, so it's a little bit easier for you to see. I found the 400 rental fee on my y-axis, and then I moved to the right until I reached a dot. Now, sometimes a dot is not going to be there, sometimes it's going to be a line, but it's the same thing. You want to match up whatever the amount is with the object line dot that is on the graph because that's representing the numbers for this rental. So I went straight across. Notice how it was side to side. Exactly. It wasn't diagonal, it wasn't anything else. It was just side to side. Step 3, move straight to the other axis from the spot and find the other value that matches up. So I'm stopping at my dot or my line, and I need to go to the x-axis. In order to get to that x-axis, I need to go straight down. So that is what I'm doing. I'm taking my dot and going straight down. I did it in blue so it's easier for you to see. And that is going to give me my answer of 20 bikes. So again, when we are plotting points, we're finding the x value and the y value and putting one dot in there. What we're doing in this is we're kind of going backwards. We're given the dot and we need to find exactly where those locations are. But those locations are actually giving us a real life example. So again, match or find whatever access you are trying to, or with the information you know. Go either up or down or side to side to get to the dot and or the line, and then move to the other axis. So straight lines, straight side to side and up and down are going to be super important for this. And then finally, what I have is just a little bit of a review for you, something that we talked about in class. We have a positive slope when we have something moving forward or going up, is when the x and the y values are both increasing. So going up, both x and y are increasing. When the line is flat, that means that the x values are increasing while the y values are staying the same. So in our examples that we had in class, for example, in the tortoise and the hare, we had when the hare was sleeping, we had that straight line because time was going, but he was not moving. And then finally, we have that negative line or that negative slope, which is when the x values are increasing while the y values are decreasing. So again, going back to that tortoise and the hare example, we had a dog that was walking backwards, and they were walking backwards because over time the distance was decreasing. So, one more little side note is that if you have to find the average speed or the speed of 1 hour, you can look back at your rate and unit rate notes, or you can do what we practice, which is looking at the graph or um, looking at the chart if that information's in there. So, either way, you have 3 ways of finding the average speed. If you have any questions, comments, or concerns, please let me know.